Hello, this is Ms. Poor, and we're going to go over Part 2, Basic Geometric Terms and Definitions. In the objectives of this lesson, you'll be able to describe the difference between postulates and theorems and how they are used in proofs. You will also be able to identify the components and purpose of a proof. Some of the new terms that we're going to be learning is postulate. That's a mathematical statement that has to be true. And for instance, through any 2 points, there is exactly one line. Then there's theorem, which is a mathematical statement that has been or is to be proved on the basis of established definitions and properties. They are never accepted as true unless it is proven. And an example of a theorem is if M is the midpoint of segment AB, then segment AM is congruent to segment MB. A proof is a method for proving that a stated theorem is true. A proof uses undefined terms, defined terms, postulates, algebraic properties, and already proven theorems. While proofs can be presented in different ways, all proofs have the same parts and follow the same general order. They have a list of given information. They also have a statement of what is to be proven. This has often got a diagram with it. If it doesn't, you need to draw one. It also has a sequence of statements that leads logically from one to the next. And then they have reasons why each statement is true. These reasons can include postulates, previously proven theorems, or accepted definitions. When we do 2-column proofs, this is how they look. Your given is going to be called your hypotheses. What you will be proving is also known as your conclusion. And your reasons are the arguments you have used to prove your conclusion. Now, geometry is a system that builds logically, and the system of logical thinking is referred to as Euclidean geometry. It's named after the Greek mathematician Euclid, who lived around 300 BC. What you need to know is that postulates are stated. When you state postulates, statements that are accepted as true, and construct proofs which are used to prove theorems. These theorems are then used to prove still more theorems. Now let's work an example. We are asked to identify the hypothesis, argument, and conclusion. The problem says, on a clock, the angle formed by the hands at 2 is a 60-degree angle. If the angle formed at 2 is congruent to the angle formed at 10, prove that the angle at 10 is a 60-degree angle. Okay, now we're not having to go through and prove this. They've already proved it for us, but what we're doing is identifying the hypothesis, the argument, and conclusion. Now remember, your given is always your hypothesis. Any information that's given to you is your hypothesis. What you have to prove is always going to be your conclusion. Notice how it says prove measure of angle 10 equals 60. The very last statement in the proof is the conclusion, and it says the measure of angle 10 equals 60. And then lastly, our reasons are always known as our arguments. That's a list of reasons that we've given, and it shouldn't have any holes in it, or loopholes, okay, that distinctly says, hey, if measure of angle 2 is 60, then the measure of angle 10 is also going to be 60. Here's another example. And again, we're asked to identify the hypothesis, argument, and the conclusion. This is your hypothesis. Notice how they've written it a little different because it's an algebraic proof. Okay? It says write a 2-column proof to show that if anything that follows your if is going to be your hypothesis. So it says if 3 multiplied by the difference of x and 5/3 equals 1, Then is always going to be your conclusion. Okay, you've got what you need to prove, your hypothesis, and then you have your conclusion, which is x equals 2. Then you're going to have your arguments, which are your list of reasons. And notice how they went through and they worked out this algebraic problem right here. And for each step, they said, oh, okay, that first part's the given. Then they used the distributive property. Then they did some substitution, and on and on and on. That's your arguments. Okay, here's a summary. A postulate is a mathematical statement assumed to be true. A theorem is a mathematical statement proven true, has to be proven. A proof is a method for proving that the stated theorem is true. And you've also seen how undefined terms, defined terms, and postulates are starting points for proving theorems. Just want to thank you again for listening to this lesson on Geometric Terms and Concepts Part 2, and don't forget to contact me if you have any challenges learning the concepts in this lesson.